welcome. This is the first screencast for Chapter 2, which is looking at science and just kind of measurements and energy. So again, a little bit more of an introductory type chapter. And just starting off looking at science and studies. This is one that's always been kind of a mystery, or may have been sort of kind of a mystery. We're always learning more about what happened on Easter Island. So you can kind of see those little statue guys. The island is supposed to have a lot of palm trees, and we don't really see any. So deforestation happened one way or another. And the old hypothesis was that, well, those people on that particular location, they just didn't manage the resources well, and they used them all up too quickly, unsustainably, and they died. It's a little bit more complicated, at least the new thinking on this. Anthropologists have been studying this for a long, long time. And when you go back and look at some of the historical records, when Europeans first showed up in the 1700s, early 1700s, there was a thriving population that was on the island. And when they came back later, things were not so rosy. More people had vanished, and there was deforestation happening. And then when they came back later, it was mostly uninhabited. Very few people there that could not have, on their own with that type of many people, have done what, all these sculptures or heads. Most of them had been knocked down at this time. So most of these sculptures you see on the island now, these statues, they've been put right back up. They had been knocked down. The thinking is now is the Europeans brought disease with them and rats, invasive species. And the combination of these two things kind of ran havoc over the island and the inhabitants. So the disease knocked out a lot of the people. They also had some social issues going on as well. So people died, just kind of contacts with others, peoples that played a part in the demise of the inhabitants of Easter Island. So the point is that with science, we're always learning more and more information. Okay, so looking at some of these things as far as what scientists do, their process is they collect data and they run experiments. They do it in a very organized way. And you can kind of see one of the way processes could go on the right-hand side is you ask a question and you collect data. And you have hypotheses, and you do research, and you just collect more and more. And then it develops. And that's one of the beautiful things about science is it's never done. We're always learning new things. Space is an excellent example. We are learning more and more about space all the time. And I think I had one. No, I'll leave that one. Okay. So one of the other beautiful things with science is the critiquing. So everybody wants to get a name for themselves, and they'll do this research, and you fall in love with your idea and you want to prove it true, and you'll finish it up and you'll say, okay, this is the answer. I've done all this research. It's fantastic. Everybody's going to love it. The rest of the scientific community will just attack that idea, trying to prove it wrong. Not because they don't necessarily like the person, but because this is part of the process. That peer review, several steps along the way to make sure that it's good science. So when something comes out, whatever it happens to be, you can bet that there's been a lot of other people trying to knock it down and prove it's not correct based upon their own studies. Whether it's a new idea or something, it's an improvement in idea. This is part of the scientific process, and it makes everything stronger and better accepted along the way. And again, the further you get along the line, you have these hypotheses, and they're accepted for a period of time. But if they keep testing them and nobody can prove it wrong, eventually it may become a theory. And then again, it's still just like, well, we're pretty confident, and that's kind of how it goes. There are some things which are usually natural, that, for example, like gravity, we don't necessarily test it that much. We just kind of accept it. And for those kind of things, we call them laws. Natural phenomenon. Okay, when you are running tests for a hypothesis, typically in an experiment, you're only going to change one thing at a time. So you have your variables. It's important to only look at one variable at a time. Otherwise, when you get results, you don't know what was influencing those results. Was it variable A or variable B? The trouble with a lot of environmental studies or scenarios is that there are many, many things going on at the same time. It's called dynamic. And it's difficult to point from one thing to a result and say that's what's happening. You could call it a correlation, that it seems that this is causing or this is happening and this is a result at the end. But we can't necessarily, unless we can isolate these other variables potentially in play, say that one is causing the other. Again, we can call it a correlation and say, okay, this seems to always be happening. And we'll talk more and more about that as the year goes on.